After the concept development stage is the engineering development stage. And in this stage, first, let's take a look at the advanced development. The objectives of advanced development is first, resolve the majority of risks brought by new technologies. Because as we all know, to develop a system, it has to apply some new technologies to upgrade the previous version, and there will be some risks brought. In this phase, we have to resolve these risks. And second is validate the system design approach as a basis for full-scale engineering. For 5G system, there are some methods. First is requirement analysis. We shall be familiar with this graph. Here are three major features, or we can say that the most urgent needs the 5G system want to meet. First is enhanced mobile broadband. And this feature will provide 5G system the power to get a very high network speed and allow many users to use the network in the same time. So the speed could be as high as several gigabytes per second. And second is massive machine-type communication. This is critical for the implementation of Internet of Things. And only if we achieve this feature can we go into a smart city. And the last is ultra reliable and low latency communication. This feature will enable many real-time applications, such as video conferencing, voice over IP, and self-driving car, and also some virtual reality games or some applications. So these three features, or we can say that these three requirements are the most important objectives the 5G system want to achieve. So here is the context in requirement analysis. The second method for advanced development is functional analysis and design, but here we will not introduce it in detail. So let's directly look at the third method, prototype development. The objectives of prototype development are first to identify issues of physical implementation involving unproven technology. In the first method, we have resolved the problem, the risks brought by unproven technologies. And here we should consider the issues that will occur during the physical implementation. And second, we should determine the level of analysis and development required to reduce risks to acceptable values. So here we can see that the basic need of this phase is still reduce the risks. And here we can take one unproven technology as an example. New waveforms and channel access applied in 5G system. So the key to achieve the 5G system is to utilize adaptive waveform and multi-user access scheme. This table shows some schemes, and here it also shows the pros and cons of each scheme. So compared to the traditional OFDM method, the traditional OFDM uses the rectangular path. And here the improvement is that these schemes greatly reduce the side lobes so that it could provide choices for different requirements for the flexibility of 5G system. And if we announce this in detail, first we can consider the EMBB feature. So in these user cases, the data rates have to reach a certain level. So the capacity of connectivity has to be high in certain area. So from the capacity point of view, LTE OFDM is the optimal choice. And that's because in LTE OFDM method, the complexity of signal processing is acceptable. Of course, it should be combined with the MIMO technology, which is also a new unproven, we should not say unproven, it's a new technology researched by many researchers. And if we consider another situation, URLLC, which means ultra reliable and low latency connection, in 5G, it used the method to separate the control plane and the data plane to reduce the latency. So the LLC, which means low latency communication, is performed in the D2D mode, which is devices to devices. We take this technology to reduce the access points between senders and receivers. So to support this complex LLC coding, the framework of 5G waveform should apply the advanced multi-carrier schemes combined with filtering functionalities to realize the multi-service air interfaces. The second part of engineering development stage is engineering design. We should first clarify that the outputs of this phase is first a test requirement and second engineered prototype. We can analyze the system from the following aspects: user interfaces, environmental interfaces, the interfaces between modular, and the assembly and installation issues. Next, we should know that there are three characteristics of a system: reliability, maintainability, and producibility. So, to design and put forward the test plans for the 5G system, we should start with these three characteristics and the trade-off between them. So for a system, the reliability is the rate that it will successfully complete its functions. In other words, it could be divided by the number of successful operations divided by the total number of operations. In 5G system, the most basic purpose of testing and evaluation is to ensure the reliability of the system. So in 5G, there are three important standards. First is the reliability of the connection, which means that the packet loss rate should be very low because the lost packets could greatly degrade the quality of connection. Second is the latency between data transmission. So in 5G system, the standard should be the standard of end-to-end latency should be less than 1 millisecond because it have to support many real-time applications, and a low latency um, will give user a bad quality. uh, Then the last is the throughput. In 5G technology, it should provide a network speed up to 1 gigabytes per second to up to 20 gigabytes per second. So this graph shows the results of the testing experiments. Here the box plot indicated average throughput for different numbers of concurrent TCP connections. Here we can see the number grows from 1 to 4 to 16. And from the figure, we can see that 5G throughput is much more powerful than 4G system. And as the number of parallel TCP connections increased, the throughput also improves. And the reason for this improvement is that more connection will utilize the bandwidth fully.